Good morning. Uh, in the last lecture, I discussed about introduction to signals. Now, this is the continuation of that lecture, and today I am going to continue with the signals operations. Though I discussed this part little bit in the last lecture also, so I already discussed this one that let me shift it. I already discussed these two operations like shifting and inverse. Shifting, I think I discussed. Inversion, I have not discussed yet. So shifting, you can see this is your original one, and you can shift this signal either left side and or right side. So if you shift it at left side, so it becomes f of t plus t, and if you shift it at right side, then you can represent the signal by writing f of t minus t. Here capital T is the measurement, means by how much time you want to shift it. Okay. Now, so I already discussed, I also give one example of your classroom, like if you consider that this time, that means the origin or the commencement of this signal, if you consider your class timing, say suppose 10 am, then if you compare this signal, that means you can say that commencement of this signal is at before 10 am or 9:30. You can consider it's start at 9:30. So if a students come for the class at 10 am, then means at present time. But if a student comes earlier, means before time, so we can say the student is advanced, or students came before the class. So we can say that this is the representation of advancement or advanced signal. Before time it already take place. Now in this case, in the last one, if we consider, so compared to the original one, so if this is your 10 am, then this maybe you can consider 10:30. So the students came late and the students entered to the class at 10:30. So that means there is a delay of by 30 minutes. So we can say that this signal is the representation of delayed signal or late signal. So when we shift this signal right side, that means this becomes a delayed signal. When we shift the signal at left side, this becomes the advanced signal. Now this is the operation of time shifting. So basically time shifting, not the frequency shifting, because the main independent parameter here time. Now the next one is this one. So last class I also discussed, in last lecture I also discussed that if I consider that present state, means the present value, say t equals to 10, then why we are writing f of t minus t and t plus t. So from this example you can understand that if I write f of t minus t and t is your, say capital T is your 2, means by 2 unit we want to shift it. So that means that if when I am writing f of t minus 2, so it becomes f of 8. So this 8 and f of 10, this is the original one, if you compare, so 8 is the past value compared to the 10. So this is the reason, that means the past value means is already delayed. So here, if this is a reason, we represent delayed signal by f of t minus t. And when the same way we can represent this one also, why we are representing f of t plus t for advanced signal or the future value. See, the when I am writing t plus 2, it becomes f of 12. It will be 12. So if you compare, f10 is the original one and f12, so 12 is the future value compared to 10, or advancement value compared to 10. So in that case, we, because of this reason, we represent the advanced signal by plus symbol and the delayed signal by minus symbol. Now coming to the another operation, this is called inversion. Some other names is also there: mirror image, flipping, reversing. So what actually we are doing here is a time inversion. So time inversion means that this is the main scale or positive t. So time inversion, so you have to invert or you have to reverse this t value. If this is positive, then you need to find out negative t. So the original signal is drawn at the positive part of t after flipping, or if you place one mirror here. If you place one mirror here, you will get one mirror image. That mirror image actually you can see in the negative plane of t, or negative part of t. So see, if you take the mirror image, it will be your actual signal, or invert signal or reverse signal. That means positive t becomes the negative t. Just you can fold the signal along y-axis, so that left side you will get one impression of the same signal. So that would be your invert signal or reverse signal or flipping signal, or also you can say mirror image. See, another example is also there, that this is your ft, just fold it along y-axis, so it will get impression at the left side of t. So that is your mirror image or inversion. So these two operations are important for signals. Basically we do this delayed or miss shifting and inversion. Other operations are also there, one by one we will discuss later. Now these operations will better to know, or will get to know in a clear way. So when we'll discuss this elementary signals. So elementary signals, or we can also say basic signals or standard signals. So to represent means many standard signals are already there. Some of the names already you have heard, you have studied in, like sinusoidal signal, ramp signal. Okay, you have already studied, you have already heard. You know how to represent this, you know their equation, their expression, how to represent them when we writing in the form of expression. So this signal, now the come to the first one. I think this is not known to you. So this is a step signal. Okay, step signal. First you consider the steps function, step function or step signal. See, this is the signal, step signal. So why it is called step signal or step function? Because it look like staircase or steps. This is one step. So that's why the name is step function. Another part is also there, that unit means 1, that means the magnitude is 1. So this representation says that there is look like step and the magnitude is 1. Initially the magnitude was 0, and after that at t equals to 0 there is a certain change, and this certain change takes the signal to one value, or amplitude becomes 1 now, and after that this amplitude still continues. It dot means is continue. Yes, a continuation. So how we can represent this? So unit step function is represented by u of t. So u of t equals to 1 if t greater than equals to 0 and 0 otherwise. So see here, u of t equals to 1, that means at t equals to 0 the amplitude reaches to 1. So if t greater than equals to 0 for all values of t, if t greater than equals to 0 values are 1, otherwise 0. See, for all the values of t means if t less than 0, for all values of t when t less than 0 the value is 0. Okay, so this is the representation of ut. Now this ut we can generate in the lab also. So how we can generate? For that you need a simple 1 volt battery or DC source. Now using a switch, so that switch must be very fast, means the switching on off condition, on off changing must be very fast, then only you can generate this type of signal, step signal. See here, this changes from 0 to 1, this changes ideally takes 0 time, but when we are trying to design this, so it's not possible because we are not so correct. means we are not so quick. So what will happen if you try to generate this physically, then you will find there it will take some time to reach from 0 to 1. So this type of incline means this type of inclined waveform you will get. Okay, but ideally you will find it takes 0 time to reach to the other stable value. This is one stable value, then there is a sudden change, and again you will get another stable value after this transition. So how we can generate this? So for this you need one DC source, one switch. That switch will close at t equals to 0. Before that switch was open. If the switch was open, so across AB we will get 0 voltage, so that's why we are getting 0. Now if the switch getting closed at t equals to 0, and that too very quickly, then you will find that across AB the value becomes 1 volt. Total whole voltage is coming across AB, so we will get this 1 volt. Okay, so this way you can generate this unit step function in lab also. So this is your standard one standard signal or step function. The name is step or unit step, and representation is u of t. Now just now we have discussed about the operation on signals, no? So we can shift this signal. Okay, see there, here we have shifted this signal at the right side by how much unit? By a unit. So how we can represent it? We are shifting it right side, means minus, means delayed function, so it should be represented ut minus a. That means ut minus a means the signal will start at t equals to a. Okay, so initially values is 0. At t equals to a we are closing the switch, and then we are getting this change, sudden change. Okay, and again the amplitude becomes 1. So this way you can represent u of t minus a equals to 1 if t greater than equals to a. Okay, otherwise 0. Now if I shift the signal at left side, then what will happen? Signal, if when we are shifting the signal at left side, say by same amount, say that a unit, so it will start from minus a, because it start at negative part of t. So at minus a, so how we can represent this? We can represent it by u of t plus a. That means advancement of signal. Shifting at left side means advancement of signal. So how we can express it? So what should be the definition? ut plus a should be equals to 1 if t greater than equals to minus a, otherwise 0. This part is 0, but after t greater than equals to minus a, all the values are 1. Okay, it will continue up to infinity ideally. Now the another part is there, say this one. Now this function here, this function, see there is a two operations. Okay, two operations you have to perform. One is the shifting, that you can understand, but see the direction of the step function, that means there is one mirror image also, so there is one inversion also. So first you can consider for this u of minus t minus a. Okay, that means it equals to 1 if t less than equals to minus a. So how we can represent this? First take the minus sign common, the easiest way. Take minus sign common. So if I take minus sign common, then it becomes minus u of minus t plus a. So that minus represent the inversion, and t plus a, plus means shifting at left side, so that represent the shifting at left side by a unit. Okay, so first do the inversion, then shift it at a unit at the left side. After getting minus sign common here, you will get u of minus t plus a, so that minus representing the inversion or reversing, and then t plus a representing the shifting the signal at left side. Now this is one homework, you can try it out. Answer is already given. Okay, now next one is another function is there, which is called rectangular function or gate function. This function is also is combination of step function. See, this is the gate function. This look like gate, means say start at t equals to 0, then it will end at t equals to a, and the magnitude is again 1. So why it is called this is look like rectangular, so that's why it's also called rectangular function. But gate function is also said. That means if there is an AND gate, and in AND gate one lead you are giving says all positives, all means one passing one clock signals. Okay, and in another leg we are giving this gate function. So we know for AND gate, for how it will act, for this period only, for 0 to a period only, the another lead, if I connect that clock function will pass. Now after a, even if the clock function is connected to the AND gate, nothing will pass, because this value is 1. We know AND gate result should be the multiplication of that 2. Okay, so is a into b, like that you already know. So that's why it means for 0 to a the gate is open, after that gate is closed. So that's why the name sometimes suggests gate function also is behave as a gate. Now so how we can generate this using a basic signal or the step signal. See, the first signal which will start at t equals to 0. So first we are going to start a function or step function at t equals to 0. So this is the function which started at t equals to 0 and it will continue. So this function we can represent by u of t. But we have to restrict this function at t equals to a. So how we can restrict this, or we can consider another term, that discard, subtract. So write minus sign. Minus means we are subtracting the extra part, so minus. And then if I start another step signal, means shifted step signal, which will start at t equals to a. So what will happen then, this part, then means after t greater than a, so this part should be cancelled out, this one, but only I can keep up to 0 to a, because we are subtracting, and this part will be also there. So after subtracting it from ut minus, this is a shifted step function which will start at a, ut minus a, we can get this gate function or rectangular function. Therefore that is represented by g of t, so it's equals to ut minus a. Now another example you can consider, if the gate function start at t equals to 2 and end at t equals to 4, then what will happen? Here the gate function start at t equals to 0 and end at t equals to a. Now here magnitude is also different, say 5. So how we can represent this? So we know, if I start a gate function at t equals to if I start a step function at t equals to 2, so we can represent this way. At t equals to 2, one step function is started. When I am writing u t minus 2, so amplitude should be 1, but we need amplitude should be 5, so we will just multiply 5. So 5 into u t minus 2 will give you this step function, which will start at t equals to 2 and magnitude is 5. So how long it will continue? Because it will continue up to 4, we have to restrict this at t equals to 4. So restrict or discard, so that's why minus sign. So start another step function with same amplitude 5, and then we can write ut minus 4. So at t equals to 4 it started, so ut minus 4 multiplied with 5. That means now after subtracting only 2 to 4, this part will be there, and other remaining part, this remaining part will be discarded. Okay, so remaining part will be discarded. So this way we can find out the expression of get function in terms of step function. Next, the ramp function. Ramp function, you have already, you know already that the ramp function is look like this one. There is one slope. So this slope we can find out by y by x, that way. So ramp function is represented by r of t, and r of t equals to t. Here we are considering the slope is 1. Okay, when I am writing t, that means we are considering slope is 1. So if we have to find out the slope also. So if t greater than 0, then we can write t. If t less than 0, then the value is 0. Now another important part is there. So when we are writing ft equals to t, and t is means increasing, so from 0 to 10, 100, 1000 up to infinity. That means if t reaches infinity, the amplitude also reaches to infinity. So which type of signal it is? That means the signal is the diverging signal. It is not a converging signal. So it will reach to infinity. So it's a diverging signal. So you can tell that which type of signal is the step signal. Okay, because their amplitude is constant even if you reach to t equals to infinity. Next, coming to the exponential function. So exponential function we know is represented by this way, k into e to the power minus at, and depending on this a value, if a is positive, then we will get the decaying exponential. If a is negative, then we will get the growing exponential. Now the decaying exponential means even if we reach to t equals to infinity, the magnitude is tends to 0. That means this type of signal is converging signal. Magnitude is converged to some stable value. But here in case of growing exponential, when we reach to t equals to infinity, magnitude reaches to infinity. That means it will not settle down as not a stable situation. So this signal is the diverging signal, this one, and first one is your converging signal. Now another one, this signal is very important, that is the impulse function or delta functions. Now this impulse function is often denoted by the symbol delta. Okay, and its definition is that del t equals to 0 for t not equals to 0. Means if del t equals to 0, so del t occurs at only at t equals to 0. Other than t equals to 0, it will not occur. What does it mean? That del t equals to 0 for t not equals to 0 means it occurs at t equals to 0. Okay, now so it occurs at t equals to 0. Now see here we have marked at arrowhead. What does it mean? It means the amplitude is reaches to infinity. Means for a fraction of time there is a huge force you can consider. So you can means take one example, the practical example, like when if there is any cricket match and one bowler threw a ball, say maybe loose ball, so in that what will happen, the batsman will hit that ball so hard that ball will goes to over boundary. So you can think that the contact of ball and bat is occurs for very few very lesser time, maybe for some microsecond or millisecond time, but within that time one huge force generate, and that huge force throws the ball outside that boundary. Same thing occurs here. That means there is a, for very few seconds, one huge force generate. Okay, that is means one huge force generate. So this is actually the impulse function which occurs at for very few time, for very short span of time, and generate a huge magnitude. That's why this arrowhead is given. Now if we stretch this, so suppose we are able to stretch this, means zoom this. If we zoom this, what will happen? See the right side, after zooming it, we are getting right side a by 2, and the left side we are getting say minus a by 2. Okay, after zooming it, but a tends to 0 because it occurs at 0 only. So we are considering a tends to 0. So 1 by a should be infinity, then means magnitude is infinity. So this way also we can represent the same delta signal after we stretching it. So what should be the area under this? So area under this curve is the height into width. So when we multiply this, area becomes unity. That is represented by this expression. That means we are considering the whole time scale from minus infinity to time plus infinity, where delta is representing the amplitude, which is 1 by a, and dt is the width or the span or the time scale, means for which sort of period, which short span of period it occurs, which is representing by delta, and it becomes 1. So the area under this is unity. So whenever you express the impulse function by some expression, then you have to mention both the expression. First one is delta equals to 0 for t not equals to 0, and also area under this impulse function is always unity. Now this function also you can represent, you can compare with the gate function just now we discussed. And that gate function, if we compare with the gate function, then we can express this way also, where we for simplicity you can keep the part for positive part only, and if I give it only for the positive part, then see the one first part will start at t equals to 0 and it will end at t equals to a. So this is only written here ut and then minus ut minus a, and the what is the magnitude? Magnitude is 1 by a, but a here is tends to 0, so that also you have to mention. That's why you are going to write limit a tends to 0. Next one is sinusoidal function. The sinusoidal function all you know, but I say it will take some time, so it's better I will continue with this in the next lecture. Thank you.